Hello everyone again and welcome to my channel. In here we're going to be focusing more on electricity and magnetism and how the relationship between a charged particle is actually placed with respect to a specific type of magnetic field. Now in here we're going to be looking at helix and how helix is actually generated in a particular electromagnetic system. Now let's look at this particular diagram over here. This diagram that is being shown in here shows you three coordinate system, which is 3 dimensions where we have y, z and x, and along the x here we have a line that is perpendicular to the x plane, which is our magnetic field represented as B, or some people might call it a magnetic flux. Now, if I put a charged particle on this particular system here, in this case a positive charge, what happens is that it actually moves around in this kind of helix style or a string pattern as you go from here all the way to the very end of the magnetic field. Now, we're going to be focusing more on how is this actually generated and what is the velocity component that is crucial for the force that will be generated in this system. Now, in here, looking at this particular diagram, we see the path in here going from here around and around and around all the way to this very end. And if you look at the tangent to this particular curve, the tangent represents our velocity of our charged particle as it's moving in that particular pattern. Now, take note that this particular velocity of this charged particle has 2 components. It has one component which is actually perpendicular to our magnetic field, which is represented as V perpendicular here, and there's another component here which is actually parallel to that of the magnetic field. I'll call that V double line over there. Now, which one is actually crucial? Now, if we focus first on the force, for our force to be created, we need our quantity of charge to be multiplied by the cross product of our velocity and our magnetic field. Now, our cross product gives you velocity times magnetic field multiplied by sine theta. And now, if the angle between the velocity and the magnetic field is actually parallel, that is, if the angle is equal to 0, so if you're focusing on the first case, let's put it as 1, where V parallel is multiplied by this, then our angle here will be sine 0, and sine 0 is equal to 0. So we have 0 force in case 1 on the parallel path. However, if we're looking at the perpendicular path over here, then we're looking at where our maximum force is actually focused on, because in this case, once our velocity is perpendicular to that of the magnetic field, then we look at our sine at 90, which is equal to 1, and then our force is equal to Q multiplied by our specific velocity that is perpendicular to the magnetic field. Now, when we here, we need to notice that for we to find our velocity, there is a particular formula that is quite familiar, and how we actually determine this formula is based on when a charged particle is moving in a circular path. So if I have a circular path over here and I have a magnetic field that is actually pointing inward, now what I realize is that if I do the tangent of this particular curved path, which gives me the velocity, this velocity is actually equal to the centripetal speed, and the force that is generated is actually into this particular center of this circle. So the force that is generated based on the right hand rule, where this particular symbol is pointing inside, which is the magnetic field, then we realize that, to find our radius of this particular system, we need to take note that where the centripetal acceleration is equal to V squared over the radius, where V squared or V is actually a constant, or at constant speed, that is our V, then we can actually determine our force, which is equal to QVB, where this is also equal to mass times acceleration, and acceleration, as we know to be, is equal to V squared over R. Then what we have is QVB, where V is velocity, is equal to mv squared over R. So what you do in this case is that you cancel out your V's, and what you're left with is our R to be equal to mv over qb. So in this case, our velocity in here is actually now the component that is actually perpendicular to our magnetic field, that is for our V. So that is the V that we're going to be focusing on in here. So that's about it for this particular video. I hope you're able to understand the helix that is generated when a charged particle is placed in a magnetic field and it forms this particular pattern. And take note that this is actually an initial velocity that is not perpendicular to the magnetic field, and the velocity component that is parallel to the magnetic field is constant, for there is no force parallel to that particular field. So all the same, thanks for following me through this. Truly appreciate it. Hit a comment down below, let me hear your thoughts, share with everyone, and be smart. Bye.